Hi everybody, welcome to MagnoliaJS 2021. This is Speaking in Code, Hands-Free Input with Talon. I'm Blake, I'm super excited to be here. This is a recording, but you will find me hanging out in the Discord. My username is Blake, so feel free to ping me there if you have any questions or anything. If you go to blakewatson.com/speaking in code, then you can get an article version of this talk. It's not like a verbatim video transcript, but it covers all the same concepts that we'll be talking about here. So first, a little about me and my work. I'm a front-end engineer with MRI Technologies. I live in the central Mississippi area, but I work on a remote dev team. MRI, they're located in Houston, and the team is remote. Among other things, MRI provides software development services for NASA. I work primarily on an application called Cosmic, which is an inventory management system that's being used to track and manage hardware for the EMU, aka the spacesuit. For those of you who are curious, it's a Vue TypeScript web app with a Postgres GraphQL backend. As you might imagine, when it comes to the spacesuit, there is a lot of data to manage. There are a lot of parts and processes and nuances, and there's a lot of code. Some of that code wasn't typed, it was spoken. I use software called Talon to code by voice, and I often use that phrase, coding by voice, to quickly describe Talon and what it's for, but that phrase isn't really accurate. Coding by voice is just a stand-in for a broader idea of hands-free input. The technology I'm talking about isn't limited to coding, even though that's a common use case for it. Think about, like, if you're coding a website, you're probably typing code in an editor, but then you're also flipping over to your web browser to test your site. You're reading documentation in a web browser or some other application. You're using terminal and any number of supplemental tools and applications. So just keep in mind whenever I say code by voice that I'm really referring to a bigger idea of hands-free input. So why would anyone want to code by voice? Well, for me personally, it's accessibility. I have a condition called spinal muscular atrophy, which, among other things, causes me to have extremely weak muscles to the point where typing on a physical keyboard is impossible. So I need to use alternate forms of input, and one of those is I use a Mac feature called the Mac Accessibility Keyboard. And if you're not familiar with that, it's an on-screen keyboard that's built into Mac OS. But another form of input that I use daily is speech recognition. So that's my reason for using it. Other reasons, a big one is repetitive strain injury. RSI is something that's prevalent in our industry. If you search RSI and programmers, you will find a lot of articles about RSI affecting people's work and personal lives, and if ignored, the symptoms can be really severe. A lot of pain in the hands, arms, shoulders, neck, that kind of thing. And using voice here can help that. Can give your hands a rest, give your arms and shoulders a rest, and break up some of that repetitiveness of typing. Another reason is just something that I like to call magic. It's just that speech recognition is a really cool way to control your system, and it makes you think about your workflow differently and potentially do some things faster than you could do otherwise. That said, you might be skeptical about that, and I wouldn't blame you. Before I learned how people actually code by voice, all I had to compare it to was things like our smart devices like Siri or long-form dictation programs like Dragon. And in fact, I would have thought that it would have gone something like this.
We're going to do a little Perl script using the Windows Vista software recognition to show you how easy it is. Open parenthesis, Go to beginning of document, delete, O, press O. Go to end of document. Press caps lock. Info. Delete info. Press capital I. Delete capital F. Delete delete capital of. Thank you. Oh, don't do that. Thank you. Delete Delete all. Select all. Delete. Select all. Select all. Delete.
There's more heartbreak and suffering where that came from if you search Windows Vista speech recognition on YouTube. But what it actually looks like is more like this.
Start timer. Block tag template. Tag div attr id dubstring app slap. Tag harp1 go right space title hello spamma. Brace second space camel format name args word user go right space. Push bang space. Close tag slap. Close tag dedent go down slap second. Block tag script dedent. Say export default space block. Say name colgap string app comma slap. Say data args push space block. Say return space block. Say user colgap block. Camel first name colgap string title Harry comma slap. Camel last name colgap quote. Shift made air near cap harp air near drum air. Go down second semi go down comma slap. Say methods colgap block. Camel format name args word user push space block. Say return space backtick dollar brace. Say user.camel first name go right space dollar brace. Say user.camel last name push semi page down slap second tag style go left space look air near gust equals dub quote sun cap sun slap close tag dedent stop timer.
So what is this sorcery? Well, it's called Talon, and it's powerful cross-platform software created by developer Ryan Heilman. In this particular demo, he's transcribing some code using the conformer speech model that's currently in beta. Talon is available for free, but the developer does have a Patreon that you can support if you want to support the project. And if you do at the beta tier, then you can access that new speech model as well as the latest beta features. Talon enables hands-free input by three things: speech recognition, noise recognition, and eye tracking. I'll be limiting this presentation just to speech recognition because I don't have experience with the others really yet. But in short, eye tracking lets you move the mouse cursor around using the movement of your eyes and head. And noise recognition enables you to script certain actions in response to particular noises, like a hissing sound, like tss, for example. Talon's speech recognition capability is really good. It's getting better all the time. But Talon's superpower is probably its scriptability. It has its own declarative syntax for defining commands and behavior. And then beyond that, you can extend it with Python. So we'll look at some examples of that shortly. Talon does require a bit of setup to use. It needs a speech engine, which you can get from the website. And out of the box, Talon doesn't do anything in regards to transcribing. It needs configuration files or scripts to tell it what to do. There is a community-maintained repo called nosj Talon, and that's something you can use to get started immediately without needing to learn how to script your own or script Talon. It's a comprehensive command set, and right now it's essentially considered like the standard or default configuration. There's instructions on the website, on the Talon website, that tell you how to get these scripts from GitHub and install them. In time, you'll probably want to modify your configuration or even write your own commands, which is what I did. Talon is configured by a mix of .talon files and Python files that sit in your Talon user folder, and we'll take a look at that some more shortly. So what we're going to do is look at some of the concepts at play behind the seemingly nonsensical commands that you saw in the demo video of Talon there. Coding by voice introduces a new way of thinking about how you type. It's just like the way you optimize when you type on a keyboard shortcuts, you configure your editor. Well, it's kind of the same principle. We're going to do some optimizations on how we dictate code by voice. Conventional speech software works by waiting for you to talk and then transcribing what you say. Like, you talk, it types. That's what was happening in that first video with Windows Vista. Talon doesn't actually do any transcribing by default. It needs to have instructions that tell it what to do. And that might not seem like a big difference on the surface, but it actually is, because when you're writing natural language, it makes sense to speak it out loud because natural language is naturally speakable, but code isn't really speakable the same way natural language is. So you need a way to express code out loud in an efficient manner. So how do we get Talon to actually do something? We need to have something called scripts, or that I sometimes also call a command set. But it's the same thing. It's a collection of files that you put in your Talon user folder, and it's usually a mix of .talon and Python files. Like I said before, if you're just starting out, you can use the MagnoliaJS Talon scripts, and there's instructions on the website for how to set those up. That's kind of like the starter set. I wrote my own scripts because I wanted to learn how Talon worked, and also wanted to have a limited number of commands and just grow out the list as needed. I also have trouble enunciating certain words, as you might have noticed. So writing my own scripts lets me control my choice of command words more easily. But scripting Talon is enough material for a whole other talk. So I can't do a deep dive there, but I'll show you a couple of quick examples. The first is this generic Talon file where we have 3 commands. The first is we want to speak the word enter, and we want Talon to press the key enter when we do. The next one is we're using the command word next to tell Talon to enter a space. And then the last one is we're using the phrase arrow function to do 2 things. First, we'll insert a JavaScript arrow function template, and then we'll tell Talon to press the left arrow key to move back the cursor like in between the braces there, so we can type the body of the function. In the next example, it's a little bit more complicated. We're using Python this time. Essentially what's happening is in the Python file, we're setting up what's called a capture in Talon. And what it's doing is it's going to intercept any command that starts with the word runner followed by a word. And it's going to take that word and then append that word in lowercase. It's going to format it lowercase and then append it on the end of npm run. And so the goal here is I want to be able to say like runner serve or runner build, and I want it to type npm run whatever script name I said. So then in a Talon file, which it doesn't have to be named the same, but I mean we're naming it the same for clarity, we consume that capture, I guess you might say, and then we have it insert what the capture returns when we use the command. One big concept of coding by voice is using a phonetic alphabet for spelling. Computers aren't as good as humans at understanding spoken word, so it helps to use sounds that are easy to distinguish from each other. For example, think of the letter E. A lot of letters sound like the letter E, C, P, T, etc. And I mean, honestly, people also have trouble telling the difference sometimes. Like if you've ever had to spell your name over the phone and you had to say like A for apple, A as an apple or something like that, then you know what I'm talking about. But military and other organizations solve this problem with a phonetic alphabet. The most popular one is the NATO phonetic alphabet. And so you probably know some of these like Alpha, Bravo, Charlie, Whiskey, Tango, Foxtrot, etc. But for speech recognition, we want shorter words. Like I don't want to have to say November every time I want to type an N or whatever. So let's look at what I call my Talon alphabet. I'm going to switch over to VS Code and also show you my Talon notification window. It will tell you what commands I'm speaking. It's asleep right now. But I have a file that defines my phonetic alphabet in Python. And then in this plain text file here, I'll just demonstrate. I'll try to say these real quick so you can see how it works. Talon wake, air, bill, cat, drum, each, faint, gust, ham, sit, jury, crunch, little, made, near, orange, pink, queen, red, sun, trap, urge, vest, wet, plex, yank, zoo, Talon sleep. So that's my Talon alphabet. I will say that now that I've committed this alphabet to memory, I actually have trouble spelling things out loud for people without using my Talon alphabet. It's kind of funny. To code by voice, we need to be able to accurately input all the punctuation and symbols and special characters that are everywhere in code. Keyboards have limited space, so the way they do this efficiently is, require you to hold down a modifier key, and so that they can reuse keys for multiple characters. We're dictating by voice, so we don't have this same limitation. So we won't say things like Shift 9 to type an open parenthesis, for example. We'll use whatever commands we want, and you can use whatever commands that work for you, but whatever you use, you'll want to make sure you include all the different symbols and punctuation that are found in the different programming languages. We'll flip over to VS Code, and you can see this is my same Talon or my same Python file rather that has my phonetic alphabet. And it also contains the list of characters and punctuation symbols that, I think this is essentially all of them that you can type with the keyboard, except for extremely rare characters. But I'll just flip over here to this same file, and I'll just type a few to show you how it works. Talon wake, slap second, paren, r paren, next, equals, wrangle, next, brace, r brace, enter, question, bang, dot, dash, square, r square, hash, Talon sleep. That's just an example of me dictating some characters off the top of my head. What we've looked at so far essentially covers all of the individual keys, but we don't necessarily want to speak each individual letter or symbol. That's slow and tedious and annoying. Instead, we'll use the concept of formatters, which is where, in my opinion, the real power of Talon starts to show. Formatting commands often work by starting with a trigger word and then following that up with the text to be formatted. So, for example, if I say camel hello world, then my formatting script knows that I want to type the words hello world but rendered in camel case. And we'll switch over to VS Code and take a look at that in action. I have more formatters than these, but these are the ones I'll demo. Here's some that are used for programming, and I'll describe these below. Here we go. Talon Wake. Next. Camel Hello World. Dune. Dune. Next. Kebab Hello World. Dune. Next. Snake Hello World. Dune. Dune. Next. Yellow Hello World. Talon Sleep. So those are some basic casing that you would use. There's another cool formatter. I pulled this from the community repo, NosJ Talon repo, but it's called shrink, or my command word is shrink, and it takes all of these different words where in programming you would use like the abbreviated form, and it's a huge list. I don't even remember I don't have these committed to memory, but whenever I think that it might be in this list, it is. It's pretty cool. I'll see if I can remember a couple of them. Talon Wake, next. Shrink Administrator. Next. Shrink Define. Next. Shrink Constant. Talon Sleep. That's just a handful of ones. Now when you want to insert an actual string of text that you want to dictate, like a chat message or a code comment or something, you can use formatters for that as well. So let me just show you a few of those. Talon Wake. Next. Say this is a test. Dune. Dune. Next. Sentence this is definitely a test. Period. Dune. Next. Title I said this was a test. Escape. Talon Sleep. Talon Sleep. So yeah, that's an example of how to insert just regular text, not necessarily for programming. Oh yeah, just for fun. Talon Wake. Talon Wake. Enter. SpongeBob, just kidding, this is not a test. There you go. Talon Sleep. When I first started using speech recognition for coding, I felt helpless because I didn't know how to fix my mistakes when they happened. But you make mistakes when you type on a keyboard too. You just aren't bothered by it because you have the confidence to fix your mistakes quickly. So I believe that this is important for coding by voice, that you feel confident to use the same tool to correct your mistakes. And a big part of that is cursor movement and text editing. You can see here on the slide, I have a command called killer that I use to backspace twice quickly. That's just a little thing that I use, but I'm going to flip over to VS Code. And I'm just going to move the cursor around, select some stuff, delete some stuff. Just mess around with it to give you an idea. Talon Wake. Lexi. Junk. Jeep. 10th. Clap. Scram. 2nd. Kebab I don't know. Dune. Dune. 5th. Jeep. Peg. Rexy. Delete. Sleeper. So that's just some nonsensical randomness there, but you could see how I could travel by word. I could use directions. I don't use up, down, left, right. I use weird words for that, but that's okay. And then you got a little sneak peek of my repeater system. So it uses like ordinal words. Like I can say a command, Jeep, to go up one, and then I can say 10th, and it will repeat that 9 more times so that if I say Jeep 10th, then that's go up a total number of 10 times. So that's just scratching the surface of text editing and movement. So that wraps up the demos. Just a few things to consider when using Talon. You're going to need a good microphone and a quiet background. Keep in mind that it does take some technical setup to get started. After downloading Talon, you'll need to get the speech engine, the speech model, and some scripts. You might find it overwhelming at first to have so many commands to learn. But fortunately, if you're using the MagnoliaJS Talon scripts that I've been referring to, they come with a nice contextually aware help menu system, and you can call that up and it'll give you a reference of commands that are available to you. If you want to dive deeper with customizing your scripts, you'll need to know some some Python, and learn about how Talon scripts work. I only dabble in Python, and that was enough to be able to write what is at least a useful starter command set for myself. So you definitely don't have to be an expert at Python or anything. There's also a great Talon community. They're one of the nicest tech communities I've been a part of. The developer of Talon, Ryan Heilman, is very active in the Talon Slack and is willing to help users with setting up and using Talon. Talon's documentation is a work in progress, but the official docs will get you through like the installation and the setup and getting scripts and stuff. At the time of this presentation, the best place for learning about Talon scripting API is the Talon community wiki. And like I said, the Talon community is nice and welcoming, and so you can get help on Slack with scripting, as well as other things like which microphones work well, that kind of thing. I was deeply inspired by Emily Shea's Perl Out Loud talk. It's about an older version of Talon, but it's all of the same concepts. So you should definitely check that out. You can search for that on YouTube and find it. That was a really great talk. And yeah, just thanks for listening. And you can find me at in the MagnoliaJS Discord or at any of these places. And if you need any help with Talon, feel free to reach out. Thanks.